Okay, so in this block today, this is Agile Mind Section 3, Block 3. And we're going to be deciding whether two quantities are in a proportional relationship by looking at tables or graphs. We're also going to be able to identify the constant of proportionality or unit rate in tables and graphs. And we're going to be able to represent proportional and non-proportional relationships with equations. So, today, we're going to be in patterns in proportional relationships. And so, to start, I want you to think about all of the concepts that we've learned dealing with proportional relationships, even thinking about the constant of proportionality. So, I need someone to tell me how you know if a relationship is proportional. How do you know?
It has one to anything.
Say that again.
It's like something to one.
Okay, that would be a unit rate.
Oh, my bad.
All right. So, but tell me this, how would you know if like one ratio was proportional to another?
I forgot what proportional meant.
Like equal to or equivalent to.
Oh, you can use a graph.
Okay, so if we're looking at a graph, how would you know if it's proportional or not?
If the line goes straight, a straight line.
Good, right. That's 100% correct. So if the line is a straight line and it passes through the origin, it is a proportional relationship. If we're looking at two ratios, say we have 2 to 4 and 4 to 8. Is that a proportional relationship?
Yes.
Why is it proportional?
Because I'll try to go. Yeah. You couldn't help me. Is it because you can do it times two? You can do the number times two and get the answer.
That does make sense. Okay, so if we took 2 to 4 and we multiplied 2 by 2 and we multiplied 4 by 2, we would get 4 to 8. That is 100% correct. Good job. All right, so knowing what we know about a proportional relationship, how might we be able to tell if a relationship is not proportional?
If I'm going to go back to the graph thing, if the line isn't going straight through, if it's like crooked,
Okay,
slanted,
good. Then it's not proportional. What if you have a straight line, but it doesn't pass through the origin?
it's not proportional. Because
Correct.
it has to go through the origin.
Great.
Non-proportional.
Correct. What if we had like the ratios 1 to 2 and 3 to 8? Are those proportional to each other?
No, they're not.
No.
All right. Tell me why.
Because, wait, what were the numbers again?
1 to 2 and 3 to 8?
You can't really.
Oh, I know. Let me go. Hey, let me
Okay, go ahead.
Go
Because
ahead.
you cannot times 3 by anything to get 8.
Okay. All right. So, like for instance, thinking about what he's saying, if we were to do what numbers did I say? 1/2 and 3/8.
One to.
All right. So 1 times 3 is 3, right?
Yes.
But if I do 2 times 3, do I get 8? No.
No.
And since I don't get 8, then that means it's what?
Not proportional.
Not proportional. Good job. Y'all are on a roll. All right. So I want Miss Sarah to read this first page for us, please, ma'am.
Okay. In everyday life, you will find many situations in two quantities are related. In the rest of this exploring, you will investigate two scenarios involving the cost of pizzas. One scenario involves a proportional a proportional relationship, and the other involves a non-proportional relationship. Play the animation to begin your investigation. I don't know what's wrong with my throat.
That's okay. Each pizza costs $7. Each time you buy another pizza, the total cost for your order increases by $7. So, knowing that, is there a constant rate for the cost of pizza?
Yes. $7.
Yeah.
$7.
Good job.
$7.
So that means no matter how many pizzas we buy, they're always going to cost how much?
$7.
All right. So if we buy one pizza, that would be what?
$7.
If we buy two, it would be
$14.
good
Then
deal.
if you buy three, it's
Pause.
21.
They cheat because they already got their mic on mute.
All right, good deal. All right, so let's take a look at our animation.
Azami, mute your mic, you cheating.
Yeah, everybody needs to make sure it's muted. So if we buy 0 pizzas, it's saying that it cost how much?
You don't get $0.
Yeah, because you're not buying anything, right? So it says drag a pizza into the oven and watch what happens to the table and the graph when we buy one. So if we buy one pizza, that didn't work.
The one.
One.
We spent $7, right?
Yes.
Right.
2, y'all said was 14.
20.
3 is 21 and the
Right.
other is 28.
Oh, good job. So the total cost of 4 pizzas is how much?
$28.
All right. So it says use the data in the table and graph to write an algebraic rule to represent the situation. Play the next panel when we're ready to check our work. So, just like we learned the other day, if we go 1 to the right, and we're going up how many times?
To the left.
7.
7. We go over 1, we go up how many?
14.
Which would be how much?
7.
Yeah. If we go over 1, we're going up 7. We go over 1, we're going up
7.
All right. So we know there is a constant rate of what?
7.
7.
So how can I write an algebraic rule or equation to show this information? What could I come up with?
I don't know.
Think about what we did in yesterday's class.
What was the question?
I'm looking for an equation or a rule to show that each pizza that we buy costs $7, no matter how many pizzas we buy. We'll always be able to figure out the total cost. Good.
Time X.
Good job. Y equals 7 times X. Great job. Let's check our work. I know it's right. All right, so far it shows that repeated addition can also be represented as multiplication. We already know that. We're looking for what they get down here at the bottom. So it says for any number of pizzas, we're going to represent that with X. And X, remember, is a variable that stands in for an unknown value. So they say any number of pizzas multiplied by 7 will tell us the total cost. So they get Y equals 7X. Is that what we got?
Yes.
Yeah, good job. All right, so it says, what do you notice about the graph? Can you tell me if question 2 in our workbook is the same as this question?
Mm-hmm.
Can you repeat that? Because Jamal talked in the middle of that.
Okay, I was saying, is question number 2 in our workbook the same as this question that says, what do you notice about the graph? So far, we should have answered question 1.
Are we in our workbook or something?
Yeah, we're supposed to be in our workbook.
Faith, what page are we on?
Faith, what page are we in?
69.
All right. I think we're past 69 today.
Oh yeah, it is just like Mr. Meyer.
I thought we were in page 72 today.
Yeah, we showed it. We just got done with 71. Oh yeah. No, we in 73.
Okay, 73. Today we're going to be in page 73. All right.
Oh, we gotta get them piece of stuff.
That's right. So go ahead and answer your question 1 and question 2 right now. in your workbook, and whenever you get question 2 answered, let me know what you wrote.
All right.
I'm going to give you about 3 minutes to do that, and then we'll resume.
All right. So he was saying like high is 2 sevens, right? And then that equals like it was 2 sevens and then equal to 2. But then it's 2 times 7 equals 14.
Correct. So that's saying that 7 plus 7 is 14, and we know
But
that 2
but they
times
put
7 is also 14.
so they putting the 2 sevens together and making it 2, and then times 7 equals 14.
Correct. Good job. Does everybody understand how that's working?
Yes, sir.
Perfect. So basically what that's telling you is, like on this last one, 4 sevens is the same as saying 4 times 7. All right, good deal. So the question that was supposed to be answered was, what do you notice about the graph? So Halen started answering that. She said something. What did she say?
What?
Anybody remember what Halen said about our graph?
She said that mother got a straight line.
It's got a straight line, and it
And
does
No,
what?
I said
It
it's
goes through the origin.
And it passes through the origin. That's correct. All
Well,
right.
we don't got that X though. We don't got that X though.
No, you're not gonna put X on there, because X just represents an unknown value. So basically, like if we put a number in for X, let's say X equals 5. If X equals 5, 5 times 7 is what?
35.
35. If we said that X was 6, then Y would equal what?
14, 42, I mean.
Yeah, 42. Good. So
Hey,
I want you to try to think about the equations that we could use to represent the situations in question 2A and 2B. So what does 2B say?
if you have exactly $84 to spend, how many pizzas could you order?
Okay. So I want you to put 84 in for Y. So that's 84 equals 7 times X. So we're looking for X. So to find X, how can I get this 7 by itself? What would I need to do?
You need to
You said it right. You're right.
divide.
We divide by X. And if we divide by, not divide by X, we're solving for X.
So
You
we
gotta
divide
divide
12.
84 divided by
So since we're trying to solve for X, we are dividing by 7 on both sides. And so we know that 7 divided by 7 is 1, and we know that 1 times X is just X. But to figure out what 84 divided by 7 is, we can take our calculator, or you can use your amazing brain and do 84 divided by 7. And somebody told us the answer already. They said it is 12. So they bought 12 pizzas.
really easy.
Good. Okay, so let's see what 2C is. What does 2C say?
2C say, what if you buy 0 pieces? How much would it cost? Does your answer make sense?
Okay, so we should know this from our table.
Right.
Lainey, what does it tell us in our table about buying 0 pizzas? Mm-mm. Lainey, what's it say about buying 0 pizzas?
It says it costs $0.
That's correct. All right. Somebody tell me why, if you buy 0 pizzas, it costs $0.
Because you ain't getting some.
Correct.
Yeah.
You didn't buy nothing,
don't
so it doesn't
want
cost
some.
anything.
Because
Good.
you ain't getting no pizza.
Good. Good deal.
Well, I'll be a little bit mad.
All right. Let's look at the next thing.
This said, does your answer make sense?
Okay. So does that make sense?
Of course.
Based off of what Jamal just said, he said, if you don't buy anything, are you going to spend any money?
No, you ain't
Yeah.
gonna
So if you don't buy anything, you don't spend any money. So yes, it makes sense. All right. If you could, would you read? Okay.
Sometimes gonna be free.
Well, yeah, but we're not really talking about that right now. We're saying if every pizza that you get from this store costs $7, if you buy 0 pizzas, then you're not going to spend any money. Right?
Oh, I didn't know you can.
Right.
Yeah, you should.
I got you. All right. So, Miss Layla, would you read this for us, please, ma'am? The whole question?
What if you want some pizzas delivered? Medium cheese pizzas cost $7 each, and there's a one-time charge of $5 to have your pizzas delivered. To find out how much any pizza order costs, you need to describe the relationship between the number of pizzas you order and the total cost of the order, including delivery. Think about how to represent this relationship with a table, a graph, and an algebraic rule.
Thank you. All right. So, looking at this, what do you think we're going to be looking for, class?
Find how much the total cost of the order, including delivery.
All right. So, let's take a look at our animation. So looking at this, it says, is this what you expected? What patterns do you see in the process? So it says that if you have a pizza delivered to your house, you're paying how much?
$7?
No,
I mean, $5.
$5. So no matter how many pizzas we buy, the delivery charge is always going to be what?
$5.
$5. So we can still find out how much our pizzas cost, but after we find out how much our pizzas cost, what do we have to do?
Add the delivery charge.
Correct. Great job. All right. So the process is exactly the same. So I want you to think about like how we created our equation earlier, where we said that y equals 7 times x. Would we be able to use that exact same equation here, or would we have to change it so that it would work for this new fee?
Would we? I think we would change it.
Okay, so how could we change it so that it would work?
Honestly, I don't know. I just know that we should just change it.
Well, what's the only thing that they did to change it?
They added.
Yeah, they added.
They
So,
added 5.
so
They added.
can't we just say y equals 7x, and then what would we need to do?
Plus
Plus what?
5.
Yeah, that's all. That's perfect. All right, so let's see what they did. So this is exactly the same as Jacaden said. And it says the pattern can also be represented as multiplication. Could we write the algebraic rule that describes the situation? So remember, we should be on question 3 in our workbook right now. So make sure that we have our process and the number of pizzas written down. If you haven't done that, go ahead and do that now. And so we're going to check and see if our equation that we came up with is exactly the same as the one that they did.
Mr. Mar, how you been hearing me the whole time?
A lot of the time, yeah, I can hear you.
But you didn't hear me the last problem.
No, I did not.
My computer's lagging.
Uh-oh. I can hear you now, though.
That's at least something.
All right, so is that the exact same equation as what we said?
Yes.
Yeah, the only thing that they did was instead of saying 7x plus 5, they said 5 plus 7x. Does it matter what order our addition's in?
No.
No,
No,
it
because
doesn't.
you always gonna know that the piece is $7.
Say that again.
No, it does not matter because you gonna always know that the pizza is $7.
Great job. Great job. All right, Isaiah, tell me what you notice about this graph.
You mean the graph right in front of me?
Correct, the graph that's on the right side.
Oh, you mean the numbers of pizza number cost? Oh, the graph is going up however many times you buy a pizza.
Okay. So if we're looking at this, are we able to tell if it's a proportional relationship or not?
No.
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 All right, so y'all are saying no, it's not a proportional relationship, or you're saying no, I can't tell.
No,
I
I
can
can't
tell.
tell.
Okay. So we said that in order to have a graph that shows a proportional relationship, that it has to have a straight line and it has to pass through the origin. So we know that the origin is right here. So to Chandra, is this graph showing a proportional relationship?
No,
No. Why?
because it's not passing through the origin.
Perfect. All right. So the reason that it's not is because we had to add what to everything now? $5. All right, because we're having it delivered. So it messed it up. All right. So it says, how can we use the graph, the table, or the algebraic rule to find the cost to buy 8 pizzas and have them delivered? So I still want you to try to focus on using that equation. So remember that the equation they gave us is right here. So I want you to use this equation and see how much it would cost to buy 8 pizzas.
You said buy 8 pizzas.
Mm-hmm.
That'd be like $56.
All right. So what do we need to put in place of x?
8.
Correct. And 8 times 7 is what?
56.
56. But they charge us how much to deliver it?
5, so it would be 59.
Close.
No.
61.
61 is correct. Good, because 56 plus 5 is 61. Well, they didn't show it. I thought we were going to have a table that showed it. So we're going to do it real quick. 7 times 8 plus 5. All right, so we're saying 56 plus 5 equals $61. All right. So everybody should have been able to answer question 3 and question 4. So if 0 pizzas are purchased, do we have to pay $5 to have it shipped to us?
No.
No, because you're not buying anything.
Perfect. Okay. Good deal. So looking at this, is there anybody that's confused with what we've done so far? If you are, don't be afraid to speak up. That's what I'm here for. I'd rather you tell me I don't know what's going on now than take the test and be like, what in the world am I looking at? Okay, we're going to go to page 7. All right, page 7. It says compare the representations of the 2 pizza situations. How are the situations, the tables, the graphs, and the algebraic rules similar, and how are they different? So, somebody in your own words, tell us what we're trying to find.
How are all these similar?
Yeah. What's another word for similar?
The same.
The same. Good. And then the other one is saying how are they different? So we're trying to see how they're not the same or how they're not alike. Okay. So looking at the pizza without delivery and looking at the pizza with delivery, how are they the same and how are they different?
They're different because one of them goes through the origin while the other doesn't.
Okay. What's another thing that's different about them?
One of them is proportional and one of them isn't.
Correct.
One of them starts at 5 and the other one starts at 0.
Correct. So how are they both alike?
They both go. I actually don't know.
What type of lines are they?
They both have straight lines.
Correct. And they're both dealing with the total cost that the pizzas cost, right?
Right.
And then it's also the same as because we're going by the same number of pizzas. The only thing that throws off the total cost. So like we can say total cost, but we can't say the cost of pizzas because over here they're adding $5 to the pizzas, right? Yes or no?
Right.
Good. All right, so read that for us, please, Roy Kia.
Lane, you're muted.
Roy Kia, will you read this for us, please, at the bottom? Somebody get Roy Kia's attention, please.
Roy,
Can you
Kia.
do
Roy,
it?
Kia.
Get up. She still go ahead. She said she don't want to do it.
Okay, this is Kermit Frog. You better get up or I will stomp your kneecap backwards.
All right. Remember, when we don't participate, we're losing points. All right, Miranda, will you read this for us, please, ma'am? Miranda, will you read this, please, ma'am?
Miranda.
Which one am I supposed to be reading?
The one in the yellow.
The table?
Right here.
No, the yellow.
The situation are both related to the cost of getting pizza. In the first situation, you just buy the pizzas. In the second situation, you buy the pizzas and pay to have them delivered.
Thank you. All right, so looking at this, how are the tables similar, Makai? What's it say, Makai?
Hold on, Mr. Martin.
What's it say down here in the yellow?
Okay, see nothing but the car on the screen.
The whole time?
Yeah.
All right, so you need to go over to the right side where it shows the people. Click the people and then go up to where it says Arthur Martin presentation and click the little pen button on it and then it'll show it. You should have told me that a long time, Makai. All right, Keegan, go ahead and read this for us, please, sir.
The tables are similar. They both show a pattern of repeated addition that can be written as multiplication. 7 plus 7 plus 7 equals 3 times 7. The tables are also different.
Good. Make sure your screen's on, Keegan. All right, so this one says compare the representations of two pizza situations. All right, so looking at these two pizza situations, what do we notice, Isamian?
We noticed that the number of pizzas, 0 pizzas cost $0, but every cost of delivery is $5.
Okay. So the pizza cost is the same, right?
Yes, but costing dollars with delivery is $5.
Correct. Good job. Rosiah, what do you notice about the equations? How are they similar and how are they different?
Cause what's the question, Mr. Mark?
I think she left.
Rosiah is trying to tell us how the equations are similar and how they're different.
Can I say it?
Go ahead, Jacaden.
I'm gonna try to say it. They're different because wait, what?
Who can
Why
help?
would you still pay for delivery?
Who
You
can-
didn't get no pizza.
Who
I'm pretty sure
can?
you're supposed to read the bottom. The thing.
Oh, read about it? All right. You said you want me to read it?
I said
Yeah,
I think you're
completely.
supposed to read the thing that he highlighted at the bottom. Do you want me to read? Oh my god.
And the difference that show up in algorithm.
In the algebraic?
Algebraic rule to both rules have a 7 times to represent the pattern of repeated addition. The rule that represented delivery has 5 plus for the delivery charge.
All right, so they're both algebraic rules. Okay. They both use 7 times x to represent the cost per pizza. The only difference is for the one that has a delivery, we have to add the delivery charge. Does that make sense, Rosiah?
Yes, sir.
All right, good deal. All right, number 5. Deonti, will you read number 5 for us, please, ma'am?
Do I read the stuff you highlighted?
Yes, ma'am.
The graphs that connect the data are parallel on parallel lines. The delivery graph is shifted 5 units up because you have to pay the delivery charge at $5. Comparing to the two graphs, what are the differences in the cost for any number of pizzas?
What's always going to be the amount of difference in the cost? For no matter how many pizzas you buy, what's always going to be the different amount?
The delivery, the taxes.
All right, now Jayla, help him out.
$5 from the delivery
Why?
because after each after every pizza is shipped, you add on $5.
Correct. That chicken is funny.
Ow. That hurt.
All right. Good deal. All right, so we should have been able to answer question 5 based off of page 7. So if you did not answer question 5, you need to do that now. So what does the point 0 to 5 represent? And what does it mean in terms of the problem situation?
It meant you got no pizzas, but you paid $5 for delivery.
Smart man.
Or
Good job.
for them just to see you and be like,
Yeah.
Be like, hello.
Yeah. Like you just like you really liked how the pizza delivery person looked and you wanted to say hi.
Like, oh, I'm hungry.
All right. Let's look at page 8. Okay, if you could, would you read this for us, please, Miss Emma?
Okay. In this situation, you choose the number of pizzas that put the value into the rule that you developed and come out with the cost of the pizza. The value you put into the rule is often called the input. The value you get is called the output. In the pizza situation, the input is the number of pizzas in the table in the first column. This shows the input. The output is the cost in dollars. The second and third columns show the outputs for the two rules. Now consider the inputs and outputs. How are they related to each of the pizza situations?
All right, so it says, for which situation can you just multiply the input value by a constant to get the output? Which one can we just multiply the constant by to get the output? Is it the red or the blue?
The blue.
All right, explain. Do you just multiply by the number of
Blue.
pizzas?
Sir?
Which one do we just multiply the cost of the pizza by the number of pizzas?
The red.
The red one, because
In the blue one, you're adding 5.
correct. All right, because 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. But over here in the blue, Jacaden, we're having to do what to each one of them?
Add $5.
We're having to add $5. Correct. So
Delivery.
So the question stated, for which situation can you just multiply the input value by the constant to get an output? Which one was it?
It was red.
It was red. Good job. It was red. All right. So it says, investigate this question by testing a few input-output pairs for the situation. Did we just do that? Yeah. Yeah, we did. All right. So I want us to answer the questions that are 6 and 7 in our workbook. Okay. So looking at 6 and 7, I want us to do that now. I'm going to pull those up on my activity sheets. Can you read question 6 for us, please, Jamal?
All right. You said 6 and 7, right?
Correct.
All right. Consider the following question. For which value can you just multiply the input value by a constant to get an input value? To investigate this question, test a few input-output pairs. Start by thinking about the pizza situation without a delivery charge.
All right. So it says, when you double the number of pizzas you order, what happens to the cost of the order? So what would we say?
It gets larger.
It does get larger, but give me an example. If we double something, what are we multiplying by?
By the same thing.
By 2.
By 2.
2 times 7 equals what?
14.
14.
All right. And that is the one where we just input the value and we multiply it by the constant to get our output. So this would be the input. This is our constant, and this is our output. So that is the number of pizzas, the cost per pizza equals the total cost. It says when you triple the number of pizzas, what happens to the cost of the order? What would happen?
3.
Yeah, we would multiply by 3, or we could just add what to 14?
7 more.
7 more, good. Because 14 plus 7 is 21, and 3 times 7 is 21. So either one of those works. All right, it says, how does the number of pizzas you can order for 42 compare to the number of pizzas you can order for 14? So we know that we can get how many pizzas for 14?
2 pizzas.
2 pizzas. All right. And how many pizzas could we get for 42?
Oh, 6.
Good. How are you getting that answer?
Multiplying.
You multiplying?
I'm dividing 42 by 7.
Correct. 42 by 7 gives you this. Okay. And 14 divided by 7 gives you 2. So how does 6 compare to 2?
You can,
They even numbers.
yeah.
That's not what I'm asking. Like, if we have $42, how many more pizzas can we buy than if we had $14?
Oh,
A
you
lot
got
or way more.
4 more
Great job, Jacaden. How do you know you can buy 4 more?
because you should flip. You should add 4 more pieces.
Yeah,
How you do it though? What I did, I just flipped the numbers over.
okay. And we know that 6 minus 2 is 4. So we would say if you had $42, you could buy how many more pizzas?
4 more.
4 more. Good. Now, Jayla, will you read D?
For this pizza situation, can you just multiply the input value by a constant to get the output value?
Yes or no?
What? What you say, Miss? What do you mean yes or no, Miss Omar?
Yes.
Yes. Why, Halen?
Oh,
I don't know. I just said yes.
All right. Well, it was a great guess. All right.
Thank you.
So does anybody else know why we can just do that? Think about the red side. That's what we're talking about right now.
it's 5. I mean, it's 7.
Yes.
Or I guess I should say, think about the pizzas without delivery. Yes. For the pizzas without delivery, we can. But the pizzas with delivery, can we?
No.
No, because we got to do what to every order?
You gotta put $5 for delivery.
Great job. All right. So it says for this pizza situation, can you just multiply the input value by the constant to get the output value? Halen said yes. It was a great guess, but she was right. All right. For the pizza without delivery, yes. For the pizza with delivery,
No.
thank you, Halen. All right.
No.
Good job. All right. Looking at part 7. Let me get this erased off of here. Ooh, there's a lot of erasing. All right, and let's get Reginald to read for us, please, sir. Reginald, read A for us, please.
When you double the number of pieces you order, does the cost of the order double? Give specific examples.
Okay, so it says answer these questions about pizzas with delivery. So it says when you double the number of pizzas you order, does the cost of the order double? Yes or no?
No.
No. Why?
No, because it always says that.
Yeah.
It always
No.
says that.
So let's talk about it.
It stays the same number, but you just bring it up.
There's 2 ways.
Myself.
So what's 1 times 7?
1 times 7 is 7.
All right.
So what?
And what's 7 plus 5?
So plus 5 is
13. 14.
No, it's 12. It's 12.
I don't know. I started it wrong.
All right, you're good. All right. Now the other one, it says if you double it, that'd be 2 times 7, based off of what Najela said earlier. If we double something, we're multiplying by 2 plus
Yes.
5. What's 2 times 7?
2 times 7 is 14.
Good.
14.
And what's 14 plus 5?
19.
So is 19 double 12?
No.
No, it's not.
No,
And
because
Isamian said it wouldn't be.
Close, but no.
All right.
It's
So
24.
our answer would be no. It would not double the order. Okay. And the only reason I'm not writing no, it would not double the order is because I can't type on here right now. Okay. So
I'm mad because you keep writing faster than me. I got pencil and paper.
I got you. You're good, man. You're going to do fine. You should see whenever I used to have this tool that I could hook up to the computer and I could write with a pencil. Man, I can fly with that joker on there. I got to get it where I can use it again because I am a beast.
I think think you used it one time on us. It was really fast.
Yeah, I need to get it hooked back up. I got it at my house.
Man,
I need to bring
you
it up
write
here.
mad fast. I can't even write on this.
So it says when the cost of the order is cut in half, is the number of pizzas you order also cut in half? Give specific examples. So I want you to think back to what we were looking at a while ago. So looking at our graph, which was on page 8. Let me get back to page 8. Where do you notice that the cost is doubled? Is it doubled anywhere on the delivery?
Well, it's never doubled.
It just put up numbers.
33 divided by 2 is what?
I don't. 30, 40, 50, 16. No, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28.
It's 16.5.
It's 16.5. So that's not on there. If we do 26 divided by 2, that's 13. If we do 19 divided by 2, that's not going to be right.
Yeah.
So I'm trying to think where it would actually double and be correct.
12. 12?
But we never spend just 24 on something, do we?
The pizza delivery just give you money.
Correct. And they what their actual question was when the cost of the order is cut in half, is the number of pizzas you order also cut in half?
I want to say yes.
No.
I will. I want to say
I
no.
vote no.
No,
Okay.
it wouldn't be.
I
Yeah.
don't know.
So looking at this, it says that if we take an order and we cut it in half, I'm trying to think. Let's just say we take the original one. All right. So the first order was 0 pizzas plus $5 equals 5. So if we double this, that would be 1 pizza times 7 plus 5. We did that earlier and said that this equals 12. Okay.
Oh.
So if this equals 12 and if we half our order, 12 divided by 2 is what?
6.
6. So is that 5?
No.
No. So our answer once again would be no. If we cut it in half, the cost of the order is not also going to be cut in half. All right, because of the delivery charge. So it says for this pizza situation, can you just multiply the input value by the constant to get the output? Does that work or no?
No.
No, not for this one because we got to do what?
Cause you gotta
Don't know.
multiply.
We do multiply, but we
Divide.
also have to do what?
Divide.
No, think the delivery.
Oh, you gotta add. You gotta do.
That's right. We got to add 5 for the delivery, so it doesn't work. Good. All right. So in summary to our lesson today, the differences between proportional and non-proportional relationships was provided. All right. And so with that being said, we know that proportional relationships on a graph are what type of line?
Straight.
A straight line that passes through what?
Straight line.
I mean,
proportional.
I'm chicken.
A proportional relationship on a graph shows a straight line that passes through the origin. Great job. All right. If it's not proportional, then it will not pass through the origin or it will not have a straight line. It has to meet both of those in order for it to be a proportional relationship. It has to be a straight line that passes through the origin. If it's not, then it's not proportional. So How can we tell if a scenario describes a proportional or non-proportional relationship?
If the are we talking about the
Yeah, like just think
graphic?
about like what we just did. How
Um,
did we know that it wasn't going to be proportional?
because it didn't go through the origin.
Okay, it didn't go through the origin. And what did we have to do to our equation? Was it just a simple equation where we just take the number of pizzas and multiply by the cost?
No.
No, we had to do what to it?
Output stuff, cluster output stuff.
Yeah, we also had to add 5 to it, so it did not work. Okay,
And all of that just for pizza.
correct.